Rubber is part of everyday life. It appears in more than 40,000 products, and most importantly, in tires. About 40% of the world's rubber comes from natural sources, latex from the rubber tree. Natural rubber is flexible, durable, and essential for making tires. At the heart of every tire is a complex rubber compound. It's a mix of natural rubber, fossil-based fillers like carbon black, and synthetic rubber, all of which help improve the tire's safety and energy efficiency. This compound is cured under high heat and pressure in a tire mold. That's what gives the tire its bounce, along with serious grip, heat resistance, and durability. Carbon black plays a key role here. It makes the tire stronger and more resistant to wear. Depending on the tire type, rubber makes up 20 to 40% of the material, and carbon black about 15 to 20%. These valuable raw materials carry us across Europe's roads for hundreds of thousands of miles. But what happens once tires reach the end of their life on the road? In Germany alone, over 500,000 tons of end-of-life tires are discarded every year. Certified recycling companies collect and inspect them. Tires that can't be repaired or retreaded are sent to climate-friendly recycling, through pyrolysis, for example. The chemical recycling of end-of-life tires through pyrolysis helps to avoid waste, keep valuable raw materials in circulation, and replace fossil resources in a climate-friendly way. In modern, highly efficient pyrolysis plants, the previously shredded and granulated tire rubber is thermochemically broken down at 500 to 700 degrees Celsius in the absence of oxygen. This process produces gas, pyrolysis oil, and a solid carbon residue, which is processed into recovered carbon black, RCB for short. The pyrolysis gas generated during the process can be used for energy, making the pyrolysis process almost energy self-sufficient. The condensable gas fraction is condensed into pyrolysis oil. In this way, a large proportion of the carbon from the polymers in the tire compound can be recovered. The oil is used in the chemical industry as a substitute for fossil carbon. It is used, together with fossil resources on a mass balance basis, in conventional C4 crackers to produce monomers. The recovered carbon black allows the carbon black contained in end-of-life tires to be recovered. It is ground to a very fine, homogeneous particle size and pelletized as a climate-friendly substitute for fossil-based carbon black, which can save up to 80% of CO2 emissions in tire production, for example. Recovered carbon black is a valuable secondary raw material for manufacturing new tires and a wide range of rubber-based products: rubber flooring, seals, conveyor belts, paints and coatings, sports equipment, or textiles. Depending on the application, it can replace up to 100% of fossil-based carbon black. Pyrolysis turns waste into valuable secondary raw materials. Natural and synthetic rubber, as well as fossil-based fillers from end-of-life tires, are converted into new resources in an environmentally friendly way. An important step toward a functioning circular economy. One tire yields around 2.5 liters of oil and 3.5 kilograms of recovered carbon black through pyrolysis. More and more industrial companies in Germany and Europe are using pyrolysis oil and recovered carbon black to replace fossil raw materials, conserve resources, and reduce climate-damaging CO2 emissions. Pyrolysis oil and recovered carbon black stand for the shift toward a true circular economy. Instead of burning fossil resources, rubber and carbon from end-of-life tires are returned to the cycle and reused. This paves the way for more sustainable industrial production. Pyrolysis of end-of-life tires is not the end, it's a new beginning. Rubber and carbon stay in the cycle, and on the road. Let us take responsibility, together, for us, for our children, for our planet.